What if your brain didn't follow logic? What if every time you made a decision it wasn't a process, but a collapse? This isn't science fiction. It's a real psychological theory called quantum cognition, and it just might be the strangest and most accurate explanation for how your mind actually works. Psychologists have long struggled to explain one thing. People are irrational. We contradict ourselves, change our opinions based on how questions are phrased, and sometimes believe opposite things at the same time. From a traditional logic standpoint, we're broken. But quantum cognition suggests something completely different. That your mind doesn't fail logic, it transcends it. Let's break that down. In classical psychology, beliefs are treated like switches. You either believe something or you don't. It's binary. But in quantum physics, particles don't work that way. Instead of being on or off, they exist in a superposition, multiple states at once until they're measured. What does that have to do with you? Everything. Quantum cognition suggests that your thoughts behave the same way. You don't always hold one belief or one preference. You hover in a state of potential. All your beliefs, memories, and feelings exist in a kind of cognitive cloud. And when someone asks you a question, boom, that cloud collapses into a single answer. But here's the kicker. That answer isn't fixed. Ask again in a different way and you might give a totally different response. Not because you're inconsistent, but because the question itself shapes the collapse. Sound familiar? That's exactly what happens in quantum experiments. Observation changes the outcome. Let me give you a real example. In one famous study, participants were asked two questions. Is Bill Clinton honest? And is Al Gore honest? If the questions were asked in one order, people responded a certain way. But if you simply flipped the order, the answers changed dramatically. Traditional models of human behavior couldn't explain this. But when researchers applied quantum math to the responses, they fit perfectly. This isn't just a philosophical metaphor. It's a predictive model, one that beats classical logic in explaining how we actually behave. So no, your brain isn't broken, it's quantum. Hallucinations are often portrayed as wild, drug-induced trips, but in reality, they are a complex failure of prediction. Your brain isn't simply a passive receiver of the outside world. It's a prediction machine. Right now, as you watch this video, your brain is guessing what it expects to see and hear, filling in gaps based on past experiences. When those predictions go wrong, the result can be a hallucination. Here's the kicker. Hallucinations are not about seeing things that aren't there, but rather, your brain believing it should be seeing something and then generating it. Think about it like this. Your senses bring in incomplete and noisy data, and your brain tries to make the best guess possible. Most of the time, it's right. But under stress, trauma, sensory deprivation, or intense emotion, the balance can tip. The brain's guesses get louder than reality. Suddenly, you might hear a voice that isn't there or see a shape in the shadows. This isn't fantasy. It's your brain trying too hard to make sense of silence. In experiments using functional MRI, researchers found that during auditory hallucinations, the brain's speech centers light up as if someone were speaking. No actual sound. Just the mind playing both speaker and audience. It's not a flaw, it's a survival tool turned up too high. Historically, this predictive power helped humans detect predators, anticipate weather, and read social cues. But in the wrong context, it creates phantoms. What's even more fascinating is that the brain prioritizes predictions over raw data. If what you see doesn't match your expectations, your brain will often change what you see to fit the prediction. This is called predictive coding. And it means your conscious reality is a filtered, edited version of the world, curated by your brain's internal script. In the case of schizophrenia or trauma, this system becomes destabilized. Predictions take over. The brain isn't checking its guesses anymore. It's running with them. That's when hallucinations get persistent. Imagine trusting a GPS that stopped checking satellites. It's confident but wrong. Even in healthy people, hallucinations can occur. Ever thought you heard your phone buzz but it didn't? That's a micro-hallucination. Your brain predicted a buzz and created the sensation. The more anxious or expectant you are, the more likely it happens. It's not a malfunction, it's overefficiency. The modern world overwhelms our senses, and our predictive brain fills in blanks that were never meant to be there. So the next time someone claims they hallucinated, remember they're not crazy. Their brain is just doing what it was built to do, but in overdrive.
Your mind is not just a reflection of the world, it's a sculptor. It shapes what you perceive, what you remember, and even who you believe you are. Quantum cognition takes that idea to its extreme by saying your thoughts aren't fixed. They exist in states of potential. And just like quantum particles, your beliefs don't solidify until you're forced to observe them. But what if that power could be used to manipulate you? It already is. Advertisers, political strategists, even app designers, many are unknowingly tapping into quantum-like behavior in the brain. Take framing effects. When two options are presented, the one framed more positively often collapses your preference toward it, even if the content is identical. 90% fat-free feels better than 10% fat. Or think about social media algorithms. They don't just show you content. They shape what state your mind collapses into by repeatedly reinforcing a certain context or emotion. Over time, your belief system doesn't just shift. It evolves through a process of probabilistic reinforcement. This means that your preferences, your memories, and even your values are not as stable as you think. You're not lying when you change your mind. You're just shifting to a different mental state based on new context. And here's something even more mind-bending. Your memory doesn't store the past like a recording. It stores fragments and reconstructs them, on demand, reshaped, each time by your present mental state. So when you remember something, you're actually recreating it, and in doing so, altering it. This explains why eyewitness testimony is so unreliable, and why emotional memories can feel more real than factual ones. It's not that your brain is inaccurate. It's that it prioritizes meaning over detail. It chooses the version of the past that best fits your current self. This isn't a flaw, it's quantum adaptability. Now imagine what this means for identity. If your beliefs, values, and memories are probabilistic and fluid, then your sense of self isn't a fixed core, it's a dynamic process. You are not a noun. You are a verb. You are becoming moment by moment. Quantum cognition doesn't just change how we think about thought. It changes how we think about people. When we realize that contradiction and change aren't signs of weakness, but signs of complexity, we gain empathy. We stop seeing others as hypocrites and start seeing them as evolving waveforms just like us. So when someone disagrees with you, ask yourself, are they wrong? Or are they just collapsed into a different moment of potential? And when you feel unsure, confused, or in conflict, don't fight it. That's not a flaw in your thinking. That is your thinking. You're not broken. You're quantum.